Hello everyone, myself Sakti Sarup Chaudhary, and today I'm going to talk about basic heat transfer. In this course, we will be talking about very basics, fundamental of convection, conduction, and radiation. Now let's get started. Before we go to heat transfer, let's analyze what is heat. Heat is a form of energy that can be transferred from one system to another system as a result of temperature difference. Now, the analysis of heat can be done by two methods. One is thermodynamics, another one is heat transfer. Well, we are very much friendly with the term thermodynamics. But how we will define it? The thermodynamic deals with the amount of energy that transfers as a system goes from one state to another in an equilibrium. So for example, from state 1 to state 2 in a PV diagram, when it transits, then it is said that Q amount of heat is consumed. So the thermodynamics is driven by three laws, but in these three laws there is nothing such term which correlates with time. That means how much amount of heat with respect to time has been consumed. None of the laws explain. That's why we need to analyze the transfer rate in a different math approach, which is heat transfer. In heat transfer is defined as the rate of energy transfer as a result of temperature difference. And here, for example, with respect to time, how much amount of heat is transferred in a bar due to conduction, convection, and radiation is considered as heat transfer. The unit of heat transfer is we generally talk about heat transfer per second, where a time term is involved. With respect to time, how much amount of heat is getting wasted or get consumed or transferred from one place to another place. But whereas in thermodynamics, the unit is in joules. We generally talk about in joules. Now, let's talk about the modes of heat transfer. Generally, there are three modes of heat transfer. One is conduction, convection, and radiation. When we talk about conduction, when we talk about pure conduction, then take a rod which are quite insulated in the cylindrical surface, and if we heat on one side, the heat will be transferred per unit time along the bar from one end to another end. In case of convection, when we heat a vessel, then we can see that water is getting boiled. We are giving heat at the bottom of the water, and the water displaces from one point to another point. Then it is, we say it is boiled, and the heat is transferred throughout the vessel through the movement of the particles. In case of radiation, the best example is the sun. From the sunlight, if you go and stand in the sunlight for a few hours, then your body will be heated up. So this is the best example of radiation. Now for conduction and convection, generally medium is necessary because the means of heat transfer is by means of mass. But whereas in radiation, there is no need of any medium because the radiation takes the help of electromagnetic electromagnetic wave, and this generally travels without any medium. Now let's talk a little deeper about conduction. Conduction is the transfer of energy from more energetic particles of a substance to the adjacent less energetic ones as a result of interaction between particles. Conductions can take place in solid, liquid and gases. Generally, there is a misconception that conduction only takes place in solids, but we can say conduction is more prominent in solids. But apart from this, liquid and gases, in liquid and glass gases also conduction takes place. Let's analyze how this conduction takes place. By the definition, the transfer of energy takes place from one energetic particle to another less energetic particle. That means if we heat up in the one end of the rod, this heated up regions, particles get the atoms or molecules get heated up, gain more energy, and this energy is transmitted to the adjacent atoms nearby the molecules. Because of that, we can say in liquids and gases, the collision and diffusion are the mode of conduction. But whereas in solids, collision, diffusion, apart from this, lattice vibration and free electron transfer energy is one of the methods. Because of these two methods are dominating in solids, solids behaves to have a very good conduction or better conduction than liquid and gases. Now let's talk about little bit deeper regarding collision, lattice vibration, diffusion and energy by free electron energy transfer. Generally, what happens in collision, one particle which is more energetic by gaining energy, it comes and collides with a no energy particle. Then these two particles moves and this energy is divided between these two particles. And in case of diffusion, we see this energetic particle is transferred from one place to another place. Similar in case of lattice vibration, the particles vibrate with each other and with this vibration, energy is transmission from one place to another point. In case of free electron transfer, as we can see, electrons are transmitted from here to here, then here to here, then here to here, then here to here, again from here to here. So in this process, what happens, energy in the fall, like the electrons when receive energy, they get excited and jump from one atom to another atom. So that's how free electron energy transfer occurs. Now let's talk about convection. In case of convection, convection is a mode of heat transfer where energy transfer occurs between a solid surface and adjacent fluid in a motion. That means the surface is stationary, but the adjacent fluid which takes the heat from the surface or gives the heat to the surface is moving. So if it's just kind of conduction in between the just adjacent to the surface. For example, there is a hot egg over here. The arrow marks over here shows the direction of a flow of air. These particles attach to the hot egg and take the heat of the egg and then flow away. So similarly, more particles come and take the heat and go away. Similarly, in natural convection, due to density difference, the flow of motion takes place. For example, in the air everything is still, but when we place a hot egg, the particles adjacent to the hot egg gets heated up. Because of the heating up, the expansion takes place near the gas and the density near in the gas decreases. Because of that, it becomes due to bouncy force, it goes up. So because of that, a natural flow of fluid or air takes place. That's why this is called as natural convection. And here we use a fan to drive the fluid. That's why this is known as forced convection. Now, clearly we can see convection is conduction plus bulk motion of fluid. Well, we conduct the heat to the bulk motion of fluid so that we can have a better heat conduction, heat transfer at the contact point of the fluid and the solid surface. So if we take this bulk motion out, then it will be nothing but convection will be equivalent to conduction in gases. So I have already explained these things, which is the convection is divided into forced convection and natural convection. When the fluid flowing is primarily derived with a force moment, then this is for convection, and when the fluid moves naturally, this is natural convection due to buoyancy generally. Now let's talk about radiation. Radiation generally, as we discussed, radiation is the transfer of energy emitted by matter in the form of electromagnetic waves or photons. We have electromagnetic spectrum where we can see every wavelength of electromagnetic spectrum emits some energy, or the electromagnetic spectrum carries energy and transfers. It has both particle or wave nature. So in radiation, how any matter radiates, the change in electromagnetic configuration of the atoms or molecules leads to radiation. So during this radiation, there is no medium is required for heat transfer by radiation, because the electromagnetic spectrum travel speed is the speed of light. So this is the fastest mode of heat transfer available. Now let's talk about heat transfer calculations. For conduction, convection and radiations, there are some laws which can explain the rate of heat transfer. For Fourier's law of heat conduction, the rate of heat transfer is equals to minus Ka dt by dx, whereas dt by dx is the temperature gradient, A is the area of the cross section, K is the thermal conductivity, which is a material property, and like here the negative sign is due to the heat flows from higher temperature to lower temperature. For convection, the law governing the heat transfer rate is Newton's law of cooling. Here we can see the H term is a convex term for convection heat transfer coefficient, and the A term is surface area, whereas the Ts is the surface temperature and T infinity is the fluid temperature. When we talk about the principle behind radiation, is defined by Stefan-Boltzmann's law, where sigma over here is a Stefan-Boltzmann constant, which is a constant value like this, and As is the surface of the black body, Ts is the surface temperature. Well, black body is an ideal body which emits the whatever it has absorbed, but if it is not a black body, then for for a real surface we multiply a factor which is known as emissivity. This factor defines the quality of radiation by any surface. Here we can see the temperature is in the fourth order. Because of this fourth order, at higher temperature, radiation is more dominating than conduction and convection. But in lower temperature, conduction, convection and radiation, all three plays a vital role. But radiation is a little bit less than that of the conduction and convection. So this is the basics of all heat transfer principles. Thank you for watching. Please do like and subscribe.